So she did such a great job, I really didn't even need the slide. But thank you for joining me. My name is Erica Stanley. I'm an engineering manager at SalesLoft, which is an Atlanta tech startup focused on sales engagement. There, I work on the integrations and data and analytics product teams. We actually use Angular and React, but alas, no VR. And with whatever free time I can manage, I'm active in the Atlanta tech community. I started the Atlanta Network of Women Who Code in 2013, and along with our amazing directors, Beth Lang and Angel Banks, who happens to be the co-organizer for ngATL, we continue to build events to inspire women to thrive in tech. And so we're going to get into VR with Angular, but first I just want to show you my first introduction to VR. I started working with virtual reality in the late 90s when it was still super clunky and very much in the early development stages. And actually, this image doesn't even do justice to how awkward a lot of the VR setups were at the time. This is NASA's most advanced working model of the late 90s to early 2000s, and they were far ahead of any of the VR labs at the time. And while anybody who's been paying attention to VR for the last 20 years, yes, I'm dating myself, was amazed to see VR evolve from this to this, when I was in college and in grad school trying to explain to my family and friends what I did for a living, they were all, what are even the words coming out of your face right now? You've gotten weirder for sure. And so it's just amazing to see how far VR has come and how commonplace it is right now. So why was I completely dazzled by virtual reality at a time when no one outside of the government, research universities, and only the most extreme of gamers even knew what it was or what kind of potential it had? And it was because it sat at this intersection of social science and tech that I find really interesting. And if we could really create a truly immersive experience, a truly immersive kind of virtual reality, it can not only change the way we interact with the world around us, but how we interact with each other. And it's not just games and flight simulations anymore. There are so many ways that VR is weaving its way into our life. So there are actually when I was in grad school at UNC, a lot of it was around education, but it was education for things where you needed kind of direct visual input at the time. So we were working on something that helped new surgeons learn how to become better surgeons by mimicking what current and existing experts in their field were doing. So that's one kind of application of education, of VR in education. But then think about 3D modeling and CAD and kind of 3D art. Right now, for the most part, we're creating that artwork, any of those models, we're creating on 2D interfaces, which is somewhat counterintuitive. And so there are a few tools right now that will help you build 3D objects and art in a 3D space. A few of these include Blocks and Tilt Brush, both from Google. So Blocks is more kind of creating that 3D model, where Tilt Brush is more kind of painting in 3D space. But then you also have sports and healthcare, and when you combine VR or AR with the Internet of Things and connected devices and sensors, you have some really interesting data monitoring aspects to virtual interfaces. And then kind of pushing the envelope of what we can do and how we can interact with technical kinds of interfaces. And so I definitely want you to check out Robbie Tilton's Iron Man demo, because it's pretty much like bringing the interface that you see Tony Stark using in any of the movies to our current tech space. And then there's social applications. Obviously, there's social VR for Oculus and AltSpace VR, which was just acquired by Microsoft. And now, because new browser standards and enhancements and personal machines that are vastly more powerful than anything the 90s could muster, VR development isn't just confined to government labs and top research institutions. Now, if you can develop a web or a mobile app, with very little learning curve for some concepts that are specific to 3D graphics and virtual reality, and understanding the tooling around them, you can also develop a VR application. And so let's take a look at some of that. Let's take a look at how the browser is a really interesting space for VR because, again, it's a low-friction platform. So you don't have downloads, you don't have installs, you don't have anything blocking the user from immediately interacting with your content. Anyone can create and publish VR content. It's super easy to publish VR content to YouTube and to a lot of different platforms now. And then, obviously, it's the browser, so it works on multiple platforms and devices. And so you have this kind of tale of two developers. You have web developers, which are the highest number of developers on any major platform, certainly more than any major native platform. And then you have VR developers, which have this very specific skill set for 3D graphics and kind of understanding how virtual reality works. And so there's this intersection here between kind of someone who really understands the web and someone who really understands 3D graphics to kind of make some really interesting applications. And so how does VR work? Well, headset devices use stereoscopic displays to make what you see three-dimensional and to give image depth in a similar way to how our eyes actually see. But a headset alone does not make a fully immersive experience. It only becomes immersive when we can start to track the user's motion, head and eye movements, so that when the user turns their head or moves their eyes, the environment changes too. And this is extremely important to get right, because if you don't get it right, you make all of your users sick. And you don't want to give all of your users motion sickness. That is not the way to grow your virtual reality app. And so when you take that tracking one step further, in a true virtual experience, the user should be able to interact with the objects in that virtual world. So you might want to get into things like haptic feedback, things that make the user feel like they're actually part of this environment. They should be able to kind of move around and explore the environment. So moving forwards, backwards, and being able to turn and their environment adjusting with that movement, rather than simply just kind of observing a 3D scene or in a way watching a 3D movie. When you can see, move in, interact, and sense the world around you, our brains perceive it as real. And so how do we move that understanding of 3D stereoscopic imaging to the web? So if we think about this as kind of like building blocks to give us this functionality, Webgl is kind of at the foundation. So Webgl gives us 3D in the browser. It exposes a JavaScript API and a shading language that's much like C in syntax. It's heavily optimized for the GPU, and you have the ability to customize vertex and fragment shaders. If you go one step above that, then you have WebVR, which is really the web's VR enabler. It provides an API that captures information from VR devices attached to your computer, so a headset, any controls, any hand controls you might have, and provides a collaborative, or is provided by a collaborative effort between both Mozilla and Google. And is supported in nightly builds of Firefox and Chrome. In Chrome, you do have to enable the WebVR in your settings. And then building on top of WebVR and the capabilities that it brings to the browser, you have your 3D libraries. And they give you kind of a cleaner access to your core, your camera, your lights, and your materials in such a way that you don't have to delve into kind of the lower level inner workings of the camera. Popular examples include 3JS and Babylon.js. And then you have A-Frame, which is a Mozilla effort and is an even higher level of abstraction on top of these 3D libraries. And it provides a markup language for creating simple 3D objects in the browser. So at this point, you're not even writing JavaScript. You're writing something that looks very similar to HTML to create 3D objects in the browser. And so when we look at some Angular-based solutions, they took a few different approaches. So there's one approach that builds with A-Frame, and then there's one that kind of builds on top of 3JS to provide that markup. So starting with the Angular VR starter, and I'm going to share all these slides so you'll have links to the GitHub repos. Angular VR starter is an Angular 2 solution. Here, the browser activates the A-frame script by putting it before Angular's zone.js module. This is mandatory as zone.js takes over the document register element function and expects all properties like detached callback to be set beforehand. In the simplest case, the next step is registering predefined A-frame modules that are located in the app loader. We define modules as objects that implement the IVR module interface. They carry information about their type, like A-frame, the markup that describes their structure, and also the optional scripts that come with it. In fact, one could easily add new frameworks by creating further module enums. This is an example of a simple module of type A-frame, but again, this is predefined. So this is as if you had all of the elements that you want in your A-frame in that module. In a more realistic scenario where you want it to be a little bit more dynamic, such modules would be located in separate storage. So one could, for example, query them from some REST-based service and register them on the fly. And in the case of separate storage, the module registration happens in the VR module.service and can also do deregistering of existing modules. So the second one that's more based on 3.js is NGX Webgl. And this is an Angular 4 solution. It's a little bit newer than the previous solution and is a little bit more updated. And it uses 3.js to map the WebGL objects to actual components in Angular. And this is only possible because of custom renderers. So let's dig into that a little bit. The team behind Angular is always just one step ahead. And in order to accomplish the ability to render on multiple kinds of devices and different mediums, obviously you want web for browsers. You want to be able to render to mobile via native script. You want to be able to create desktop applications via Electron and create universal applications via any number of backends. So what they did to accomplish this was abstract the actual renderer. And with this abstraction, we can use Angular's component composition, templating, binding, and then create concrete implementations of the renderer for each platform. And so we can leverage this abstraction to create WebGL components and scenes the way A-frame does, except we're using Angular as the engine and Angular-specific markup. So this is an example of rendering that markup I was just mentioning. And in this example, you can see how we can define a sphere and loop over the number of spheres defined in the parent component, setting the position of the sphere and making sure that that is based off the index of the sphere in this list. Under the hood, however, is pretty simple. It's really just, instead of creating DOM elements, we're using 3.js objects that are being created and mapped to Angular components. And so thinking about this, we have this stereoscopic kind of building blocks, but the thing that really enables this to be VR enabled is not the Angular libraries that I mentioned. You have to make sure that WebVR is functioning in your browser. And in a lot of cases, because WebVR is pretty new, you're going to need to use a polyfill. But once we have our scene rendering, we just need to make sure that we have that set, and this allows us to enter chromeless view. It allows us to track orientation and also track head movement. And so now that we are in VR, we need to use the head tracking for view navigation rather than traditional keyboard and mouse. And 3.js has great VR controls that help with that. So these are some of the tools and resources that I used. Something that I really wanted to include in this talk, but I didn't think it would fit in, was kind of a bonus on designing interfaces for VR. So this is really thinking beyond how do you design interfaces for mobile, how do you design interfaces for web, and thinking what are the specific patterns and interaction patterns that you need for VR that are going to, for instance, make sure that your user can stay in this environment for a long period of time without getting motion sickness. So check that out for sure. I think it'll be a really enlightening read or watch. It's on YouTube. Thank you so much.